back to Jackson Square. Today we're going to complete an activity called Shade Me In. Parts of wholes. Okay? We're going to look at the objective. I can use equivalent fractions, decimals, and percents to show equal parts of the same whole. So every time we have a whole, it doesn't necessarily mean it's going to be 1 or the whole is going to be 100 squares. The whole can be different every time. And parts of a whole, part out of a whole is a fraction. We can have different fractions represented even though the percentages may seem the same. So the first figure we have, I like to call it my field goal, my field goal figure. I kind of colored the shapes around it just so it could stand out a little bit more. Is we want to represent what's 50%. So we need to figure out what is 50% of this field goal. If we had to shade it in, what would 50% be? So first of all, I just want to go back and use some of our old skills. I want to use some of our conversion skills. I want to use some of the things we've learned this time, some of the things we've done in chapter 1. So first of all, 50%, if I changed it to a decimal, I would move it 2 places to the left, and I would get 50 hundredths. And 50 hundredths, if I wanted to use a fraction, would be half. Okay, so 50%. I want to know what is half of this. I could go in and shade half of this figure because I can pretty much see that it's symmetrical and what part I would shade. But what I want to know is how much is half of this figure? I need to figure out what's the whole thing and then what is half of that going to be. Okay, so it says shade a region that represents the given percentage. So for this one is easy. As we get to different figures, it may be a little bit harder to know how much to shade and how many boxes that would represent. So the first thing I want to do is count the boxes. So I'm going to count the boxes. So if I'm counting the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so how many boxes in this figure? 20. That is my whole. Okay, what's my whole? 20 is my whole. I want to know what is half of 20. So I can do this 2 ways. We know that half of 20, everybody, 10, right? We know this. But because I want to practice some old skills, I want us to, you can either do it 2 ways. You can multiply 20 times 50 hundredths, which is the decimal form, and get your answer. Or I'm going to go the fancy route, and I'm going to multiply 20 times 1/2 because I want to bring back my fraction skills. So I know whenever I'm multiplying 2 fractions, 20 is a whole number, so to make it a fraction, I put a 1 under the bottom, right? And then I multiply straight across. 20 times 1 is 20. 1 times 2 is 2. Remember that a fraction is division, so this means 20 divided by 2. So 20 divided by 2 is 10. So what would 20% of this particular figure be? 20% of this figure would be 10. So I'm going to go in and shade 10 boxes. And because this is just a symmetrical figure, I'm going to shade 10 on one side. So there we go. 50% of this figure is shaded. What is 50% for this figure? 10. Okay, our whole is 20 boxes, and half of that, 50% of that, would be 10. So that one was easy, right? We want to jump in and get something easy. So let's go to another one that I think is going to be a bit easy. Different kind of figure. This kind of reminds me of like those little Tetris pieces that you move around. This time we want 75%. We want to shade in 75%. Well, what I like about this particular figure is it already looks like it's kind of cut into fourths, 1/4, 2/4, 3/4, 4/4. So I like that it's cut into fourths because I know that 75% is 3/4, right? So again, if I want to make a percent into a decimal, I'm going to move it 2 places to the left. This will be 75 hundredths. Or as a fraction, I know this is 3/4. So when I think about shading this, I envision that 1, 2, 3 of these are probably going to be shaded and one of them is not. And that would represent 3 out of 4 sections shaded, which is 75%. But I want to know exactly how many boxes would be shaded. So for me to start, I need to count all these boxes and know what's my whole here, right? So let's see. First thing, count boxes so you can get your whole. And this time I'm just going to switch up my color. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So I have 40 boxes. Okay, 40 boxes. What is 75% of 40? Okay, what is 75% of 40? So just like before, you have two options. You can multiply if you want to. Multiply 40 times 7,500. That's one way to get your answer. Remember to count these decimal places. You have 2 places behind the decimal. Multiply as normal and then bring those 2 from the right. Or you can multiply by fractions. I'm going to do fractions because I just think this is quicker. So 40 times 3/4. Again, remember I need to make 40 into a fraction by placing it over 1. Once it's a fraction, I can just multiply straight across. 40 times 3. I know that 4 times 3 is 12. I'm jumping ahead. 4 times 3 is 12, so this will be 120. 1 times 4 is 4. And again, remember, this is division. 120 divided by 4. This is an improper fraction, so you want to make it a mixed number. You can do T-bow, do some side work if you need to. I can do this in my head. I know that 4 will go into 12. 3 times 4 will go into 0 times. So how many boxes am I going to shade? I'm going to shade 30 out of the 40. And if we're thinking about that, 10, 20, 30, 40, right? We will break it up evenly, 10, 20, 30, 40. So each one of these regions should count up to 30. Or if I want to make it look like the regions, I would shade in 10 on each one. So let's shade in the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that it? Let's see how this turns out. Okay, so if I shaded them all in completely, I just want to make sure I had 10 left over because I know that 30 out of them should be shaded and 10 should not be shaded. This didn't come out as symmetrical as I would have hoped with the shading, but it's still, you can see the 3 out of 4 end pieces are shaded. So looking at it, let me zoom out a little bit. Looking at it, you can still see that it's 3 out of 4. 1/4, 2/4, 3/4 of it is shaded out of 4/4. You can see that 75% of this figure is shaded. So what's 75% of 40? Excuse me. It is a 30. So let's try something a little bit more challenging. Here is, ooh, look at that. That's interesting. I think it looks like maybe a Batman symbol or something. This one is 33.3 or 33 and a third percent. Okay? So 33 and a third percent. Do not get terrified because you see 33 and a third with that fraction in it, right? A third just means 0.3. So what is 33 and a third as a decimal? If you've been studying your chart, you know that it's just 33 hundredths. That's the condensed version of it, right? Which represents 1/3 in fractional form. So of this nice little Batman-y symbol, we want to figure out what is 1/3 of this whole. Again, we don't know what this whole is. We want to know what's a third of it. Kind of in my mind, I can envision like some sections of it, like here and here. I think these look like this would be 1/3 and that would be 2/3, and the part in the middle would make it 3/3. But I don't know how many that exactly is, but I can kind of in my mind split it into thirds. So the first thing we need to do, correct, is count the boxes. Count boxes. The boxes represents the whole. How many are total boxes is there? Remember, every single time your whole can be different. Do not get stuck in the mindset that it's always going to be 100 boxes. Do not get stuck in the mindset that a whole is always one. Your whole can change, okay? So you have to be ready for the change. So I'm going to count my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo, that was a lot. 60 boxes. There are 60 boxes. So 60 boxes, just thinking in my head, 60, and I'm thinking about thirds. So I think my answer should be about 20, right? So let's just verify that. Again, you can work this two ways. You can multiply 60 times 33 hundredths to get your answer if you want to do that decimal form, or you can multiply 60 times 1/3, which is the route I'm taking because I just want to practice multiplying my fractions, and I think this is easier, right? So again, make this into a fraction by putting over 1. Multiply across, I'm going to get 60 over 3. Remember, fractions are division. So this is actually saying 60 divided by 3, which is 20. So my estimation skills were like right on par, right? It was right there. So I think this looks kind of cool with the little polka dots in it. It looks like super cute. So you can select which 20 you want to shade. If you want to shade the left 20, the right 20, and the middle 20. I'm going to shade 20 in the middle because I think it'll just look cool. 1, 2, 3. Okay, so these are going to represent my shaded ones. And I think I have a highlighter, yes. I can go in and highlight these. So that would be my 1/3, or my 33 and a third percent that is shaded out of this whole. So my whole was 60. How much is part of that whole? What is part of the whole? What is 33 and a third percent of the whole thing, that would be 20 out of the whole. Okay? So now that you have seen me do it, I hope that you understand how we can find equivalent fractions, use equivalent fractions, decimals, and percents to look at different parts out of wholes. And we've looked at some different wholes. We've looked at 20, we've looked at 40, we've looked at 60, and we've done 50% of one, 75% of one, 33 and a third percent. So now it's your turn to practice. You get the bonus round. You're going to do 55% of these three figures, but the whole is different every time. So how many would you shade of this one? How many would you shade in this one? And how many would you shade in that one? So let's practice these skills and see what are the parts of a whole. Good luck.